Namaste students, as it clear from the screen that today we are going to talk about the chlorine. In this video, we'll talk about the methods of preparation of the chlorine along with the physical and the chemical properties of the chlorine, and at the last the uses of the chlorine. So without any delay, let's get started. Chlorine was discovered by Skelly in 1774. So the discoverer of chlorine, discovered by Skelly in 1774, but in 1810, Davy, there was a scientist Davy, discovered by Skelly in 1774, but in 1810 there was a scientist Davy who established its elementary nature, and suggested the name chlorine for Cl2, and because of its color. So what Davy did, first of all proved its elementary nature, established its elementary nature, and second suggested its name chlorine due to its color. In our previous video, we have studied that halogens are colorful, and the color of the chlorine is greenish yellow. So because of its color, its name becomes chlorine, because in Greek word chlorus means greenish yellow, and the color of the chlorine is also greenish yellow. So Skelly in 1774 discovered chlorine, but Davy in 1810 suggested its elementary nature as well as its name chlorine due to its color, because in Greek word chlorus means greenish yellow. Now, if we talk about the preparation of the chlorine, so in 1774, Skelly discovered chlorine by reacting HCl, concentrated HCl, with MnO2. So our first method of preparation is based on the method which was used by Skelly, that is by heating concentrated sulfuric acid with the oxidizing agent. Like MnO2, potassium permanganate, K2Cr2O7, ozone, red lead, etc. So our first method is by heating concentrated HCl with the oxidizing agent. So if I write the reaction, some of the reaction if I write, so suppose MnO2 reacts with HCl on heating. This HCl is concentrated one. So when HCl is heated in the presence of the oxidizing agent, then it gives MnCl2 plus H2O plus Cl2. So we get chlorine. Similarly, when this HCl reacts with KMnO4 on heating, it gives KCl plus MnCl2 plus H2O plus Cl2. Similarly, when this HCl reacts with K2Cr2O7 on heating, it gives KCl plus CrCl3 plus H2O plus Cl2. When this HCl reacts with CaOCl2, that is bleaching powder, on heating it gives CaCl2 plus H2O plus Cl2. When this HCl reacts with lead dioxide, on heating it gives PbCl2 plus H2O plus Cl2. When this HCl on heating with the red lead, that is Pb3O4, on heating it gives PbCl2 plus H2O plus Cl2. So these are the different reactions. on the basis of the first method. In this, MnO2, KMnO4, K2Cr2O7, CaOCl2, PbO2, Pb3O4, these all act as an oxidizing agent. Similarly, one more reaction we can write: HCl plus O3 on heating gives H2O plus O2 plus Cl2. So, if we write any of the reaction, out of these reaction, any of the reaction becomes example of this method, that is by heating concentrated HCl with the oxidizing agent, and in all these reaction KCl act as a reducing agent. In all these reaction KCl act as a reducing reagent. Now, if we talk about the second method, second method is the Deccan's process. Second method is the Deccan's process. Second is Deccan's process. Now, what is Deccan's process? In Deccan's process, the HCl is oxidized. In Deccan's process, the HCl, that is the hydrochloric acid, is oxidized by the atmospheric oxygen in the presence of copper chloride at 723 Kelvin. So, what is Deccan's process? HCl is oxidized by atmospheric oxygen, in the presence of CuCl2 at 723 Kelvin. So, if we do this method, this is known as Deccan's process. So, HCl plus O2 in the presence of CuCl2 at 723 Kelvin, we get H2O plus Cl2. And the third method through which we can prepare chlorine is the electrolysis of brine solution. In the electrochemistry chapter, we have studied that if we have aqueous solution of any electrolyte, how different ions discharge at the respective cathode and anode. If you have not seen that video, I'll provide you the link of that video in the description box, and from that we get to know when we electrolyze the brine solution is the aqueous solution of NaCl. So when we electrolyze the aqueous solution of NaCl, we get chlorine at cathode. We get chlorine at anode. Because the negative ion move towards anode, so we get chlorine at anode and the different product at the cathode. So these are three methods with the help of which we can prepare chlorine, either by the method which was used by Scaly, or second, Deccan's process, or the electrolysis of the brine solution. Now, if we talk about the physical properties of the chlorine, so first is, it is a greenish yellow gas. In our previous video, we have studied that the atomicity of the halogen is 2. So they are held together by weak van der Waals force of attractions, and due to weak van der Waals force of attractions, F2 and Cl2 becomes gaseous at room temperature, whereas Br2 is liquid at room temperature and I2 is a soft solid at room temperature. So first of all, the first property is that the chlorine is greenish yellow gas. Second thing, it has a pungent and suffocating smell. Third, it is heavier than air. And it is highly soluble in water. So these are the physical properties of the chlorine. That it is a greenish yellow gas, it has a pungent and suffocating smell, it is heavier than air, and it is highly soluble in water. Now we'll move to the chemical properties of the chlorine. Now the very first chemical property of the chlorine is its reaction with the metals, non-metals and the metalloids. So if we talk about the chemical properties, the very first chemical property is its reaction with metals, non-metals and metalloids. So chlorine has a tendency to react with all three, that is metals, non-metals and metalloids. Now chlorine reacts with a number of metals, non-metals and metalloids to form their corresponding chloride. For example, Na reacts with Cl2 to form NaCl. Na reacts with Cl2 to form NaCl. Similarly, E4 reacts with Cl2 to form PCl3. Fe reacts with Cl2 to form FeCl3. Arsenic reacts with Cl2 to form AsCl3. So, the chlorine reacts with a number of metals, with a number of non-metals and metalloids to form their corresponding chloride. Now, the next property is the oxidizing property. Next property is the oxidizing property. Now, how chlorine show oxidizing property? Chlorine, in our physical property, we have studied that chlorine is highly soluble in water. So when chlorine dissolves in a water, it forms chlorine water. Just like when sugar dissolves in water, it becomes sugar solution. Salt dissolves in water to form salt solution. Similarly, when we dissolve chlorine in the water, we get chlorine water. But on standing, means on keeping that chlorine water for some time, the chlorine water loses its yellow color. Means when we dissolve chlorine in the water, it becomes yellow in color due to its greenish yellow color. But on standing, chlorine water loses its color due to the formation of two compounds. One is the HCl and another one is the HOCl, that is hypochlorous acid. And HOCl, being unstable, decomposes to give HCl plus nascent oxygen. And due to the formation of that nascent oxygen, chlorine behave as an oxidizing agent. So chlorine behave as an oxidizing agent either in the presence of the moisture or when it is present in the aqueous solution. So what is the reaction we get? Cl2, when dissolved in water, it forms chlorine water. Okay. But on standing, it loses its yellow color due to the formation of two compounds, HCl and HOCl. Now this HCl is highly stable, but this HOCl is highly unstable. So it readily decomposes to form HCl and release nascent oxygen. And due to the release of this nascent oxygen, chlorine acts as an oxidizing agent. So chlorine acts as a strong oxidizing agent either in the presence of the moisture or in its aqueous solution. Now, if we write the reactions, different reactions, like suppose if I have the acidified ferrous sulfate, so FeSO4 plus H2SO4 plus Cl2, it gives Fe2SO4 whole thrice plus HCl. Similarly, if I write SO2 plus H2O plus Cl2, it gives H2SO4 plus HCl. Or if I write Na2SO3 plus H2O plus Cl2, this Na2SO3 get converted into Na2SO4 and this Cl2 get converted into HCl. Similarly, if I write Na2S2O3, when it reacts with aqueous solution of chlorine, then it forms NaHSO4 plus HCl. When NaNO2 reacts with aqueous solution of chlorine, then it oxidizes to form NaNO3 plus HCl. So in all these reactions, it is clear that Cl2 act as an oxidizing agent, and this oxidizing agent is in the presence of the moisture. In last 4 reactions we have used water, but in first reaction we have not used water, but it doesn't mean that this reaction is without water. This reaction is in the presence of the water, means in the either in the presence of the moisture or in the presence of the aqueous solution of the chlorine. So through these reactions we get to know that chlorine acts as an oxidizing agent. So this is the second property of the chlorine. Now if we move to the third property of the chlorine, third property is the bleaching action. Bleaching action of the chlorine. Third property is the bleaching action of the chlorine. Bleaching action. Now the bleaching action, chlorine shows its bleaching action either in the presence of the moisture or in aqueous solution. Means in the dry state, chlorine don't show its bleaching action. So in the aqueous solution, what happens? In the aqueous solution, when it reacts with water, then it forms HCl plus HOCl, and this HOCl being unstable decomposes to form HCl plus nascent oxygen, and this nascent oxygen is responsible for the bleaching action also. Means this nascent oxygen is responsible for both oxidizing property of the chlorine as well as the bleaching action of the chlorine. Now if you remember, in our previous video we have studied that sulfur dioxide also shows the bleaching property. But the bleaching action of sulfur dioxide is temporary. Have you remembered? The bleaching property of sulfur dioxide is temporary. Why it is temporary? Because in sulfur dioxide, if we talk about sulfur dioxide, when sulfur dioxide reacts with water, it releases nascent hydrogen. When sulfur dioxide reacts with the water, it releases nascent hydrogen. But when chlorine reacts with the water, it releases nascent oxygen. So the bleaching action of sulfur dioxide is due to nascent hydrogen, whereas the bleaching action of chlorine is due to nascent oxygen. So if we perform the bleaching action through SO2, the substance loses its color. The substance loses its color due to reduction, because sulfur dioxide gives nascent hydrogen, whereas chlorine gives nascent oxygen. So when we react any colorful material with sulfur dioxide, it loses its color due to reduction, and as soon as we kept that substance in the air, it gets oxidized again and becomes colorful. Means regain its color. So that's why the bleaching action of sulfur dioxide is temporary. But in chlorine, the bleaching action is due to the oxygen. So whenever we kept that particular component or that particular substance in the air, it remain oxidized, and if it remain oxidized, the color remain the substance remain colorless. So that's why the bleaching action of chlorine is permanent, while the bleaching action of sulfur dioxide is temporary. So whenever there is a comparison between two, what you have to write? You have to write that the bleaching action of chlorine is due to oxidation, that's why it is permanent, whereas the bleaching action of sulfur dioxide is due to reduction, that's why it is temporary. So this is the third point. This one is the third point. Now fourth property, reaction with dilute and concentrated alkalis. Reaction with dilute and concentrated alkali. So chlorine reacts with dilute alkali in a different way and with concentrated alkali in a different way. Whenever this chlorine reacts with any alkali which is cold and dilute, so it forms a mixture of chlorides and hypochlorite. So one, it forms NaCl, another thing it forms NaOCl, NaOCl plus H2. So it forms a mixture of chloride, this is chloride, and this is hypochlorite. This is hypochlorite, where hypochlorite ion is ClO negative. Hypochlorite ion is ClO negative. Similarly, when I react Cl2 with CaOH whole twice, this is again an alkali and it is in cold and dilute form. So it forms CaCl2 and hypochlorite, that is CaOCl2 plus H2O plus H2. Clear? But when it reacts with hot and concentrated alkali, then it forms a mixture of chloride and chlorate So here it forms NaCl plus NaClO3 plus H2. So this one is chloride and this one is chlorate. This one is chlorate. This one is chloride and this one is chlorate. Similarly, when Cl2 reacts with CaOH whole twice, here CaOH whole twice is hot and concentrated, so it forms CaCl2 plus CaClO3 whole twice plus H2O. Now, if we see these reactions, in these reactions, the Cl2, that is the chlorine, undergoes oxidation as well as the reduction. Because here its oxidation state is 0, but in these two compounds the oxidation state of chlorine is different. So that's why these reactions are the example of disproportionation reaction. Disproportionation reaction. And the same reaction was performed by Br2 as well as the I2. The same reaction was performed by bromine as well as the iodine, but fluorine doesn't undergo disproportionation reaction. So this is the another chemical properties of the chlorine, that is the reaction with dilute and concentrated alkali. With dilute and cold alkali, it forms a mixture of chloride and hypochlorite, and with hot and concentrated alkali, it forms a mixture of chloride and chlorate. Now next is the reaction of chlorine with ammonia. Now in this case also we get different product when we take different amount of ammonia and chlorine. So another property, fifth property, is reaction with ammonia. So if we take ammonia in excess, as compared to Cl2, we get NH4Cl plus N. But if we take Cl2 in excess, then we get NCl3 plus HCl. So chlorine reacts with ammonia, but if we have excess of ammonia, then it forms NH4Cl and N2, and if we have excess of chlorine, then it forms NCl3 plus HCl. Next property, the sixth property, is reaction with hydrogen. Or affinity towards hydrogen. So chlorine has a very strong affinity towards hydrogen, and because of this reason, chlorine reacts with the hydrogen containing compounds also. So this chlorine reacts with the hydrogen to form HCl, and if it reacts with the any hydrogen containing compound, then it forms the product also. So it undergoes in this particular step, we can say that it undergoes substitution reaction in alkane. Why? Because it has a strong affinity towards hydrogen. So what happened? CH4 reacts with Cl2 in the presence of HU to form CH3Cl plus HCl, or it undergoes addition reaction with the unsaturated hydrocarbons like CH2 double bond CH2 plus Cl2 gives CH2Cl single bond CH2Cl. So chlorine has a very strong affinity towards the hydrogen, and because of this chlorine easily reacts with those compounds which contains hydrogen in them. Now the next property is reaction with dry slaked lime. Next property is reaction with dry slaked lime. Reaction with dry slaked lime. Dry slaked lime. So whenever the chlorine reacts with dry slaked lime, then it forms CaOCl2 plus HCl. Now in our junior classes we have studied that this CaOCl2 is known as bleaching powder, but the actual composition of bleaching powder is CaOCl2 dot CaOH whole twice dot CaCl2 dot 2H2O. So this is the actual composition of the bleaching chloride. This is not the bleaching powder. This is the actual composition of the bleaching powder, but in general we have studied that it is CaOCl2. So these are the chemical properties of the chlorine. Now we will study the uses of the chlorine. So the uses are first, it is used for bleaching. It is used for bleaching in paper industries, for bleaching of wood pulp. So it is used in bleaching, and we know that the bleaching action of the chlorine is permanent. This is the first use. Second, it is used in the preparation of dyes, drugs, and many organic compounds like CHCl3, CCl4, DDT, etc. So it is used in the preparation of dyes, drugs, and many organic compounds like CHCl3, CCl4, DDT, etc. Next, it is used in the preparation of many poisonous gases. It is used in the preparation of many poisonous gases like phosgene, and next is tear gas. Next one is mustard gas, and this mustard gas was used by German in World War I. This mustard gas is highly poisonous gas, and it was used by German in World War I. So CH2 double bond CH2, when the ethene reacts with H2Cl2, that is the sulfuryl chloride, H2Cl2, then it forms CH2Cl single bond CH2 single bond S CH2 CH2Cl. So this is the mustard gas. This is the mustard gas, and this we will prepare through chlorine. So these are the different uses of the chlorine. That is, it is used for the bleaching action because its bleaching action is permanent. It is used for the preparation of various dyes, drugs, and many organic compounds, and it is also used in the preparation of many poisonous gases, and one gas, that is the mustard gas, was used by German in World War I. So students, that's all for today. In this video we have studied about the different properties, preparations, and the uses of the chlorine. I'll see you in my next video with a new topic of the halogen family.